blast off. Okay, so let's just get into the course here. We're in week 5. I'm just going to scroll for any unread posts. Let me just dig down into these first. Okay, there's a couple from Joe. Let's just take a look. Demand price for final cost. So we can. Okay. Are you feeling more comfortable about that one now, or do you want to go over it?
Yeah, that kind of makes sense to me. It's just, you got to get it to there, you got to, it's kind of like jumping through a bunch of hoops.
There are hoops, yeah, that's true. Okay, we'll look at that one together.
But that one seems pretty straightforward to me.
Okay. Oh, here's the thing, guys, is please just respect the instructions on the syllabus here. And I'm just going to reread that here while we're looking at it.
Oh, you're supposed to make it a PDF.
Yeah, just it's okay. I just want to reemphasize though, because prerequisites, posts, somewhere in here will say PDF. Yeah, on the discussion board, post draft assignments in PDF form only. So I'll let it slide this one time, but don't post your Excel spreadsheet. And the reason for that is if it's to avoid somebody copying your work and not learning it. So and there's two issues there. One is learning does not occur. It could be perceived as academic dishonesty, and then just general error propagation. So.
What's your method of making an Excel tab a PDF? It always takes me like 10 minutes.
Oh, really?
10 minutes to figure it out.
Well,
I've done it a few times.
Yeah, here's a couple things. Yeah, so good. I mean, here's what I'll do. Let me just pull up. Let me just pull up my week 4. Yeah, so for me, I have already built in, I have file, I just have save as PDF built into my computer. I don't know if you've got that or not.
Seems like everything should just have that.
So I hit that guy, and then I can just do the entire workbook, convert to PDF, P2 compressors. And for me, then it's just done, that's it.
You have to go like export.
Another thing too that you could do is you could do a screen grab. So all I'm going to do is just hit function print screen, and you can come into something like PowerPoint, then just paste it, and then in PowerPoint you can save as for example, so in PowerPoint you can I'm not sure why I'm, oh, here you go. You could just save it as a JPEG.
Okay.
Well, I also have PDF as an option on my PowerPoint, but I'll just save it as a JPEG.
And that's okay too.
Yeah, it's just something you can see. Everybody can read a JPEG. Yeah. Okay, so. Those are the only two questions I saw. Do you feel like comfortable moving forward on problem on week 4? Okay, let's look at week 5 right now, because there are a few things that can be a little confusing, and I'm just going to click on this power factor discussion really quick and see how that thing rolls. Gave this last week. 14. Yeah. Well, let's dig in there. I think we spent enough time looking at we spent a lot of time looking at the financial functions. Like we got all 6. Okay. Well, I hope I am 5. Tell me where I should hit. The power factor in 213 needs to happen before it does in 214. So I think this is one issue, is that 213 probably hasn't covered power factor yet, has it?
Yeah.
However, it has some
additional
form
short
exercise to
Okay.
power factor, yeah, okay. This is a monthly power factor. I'm just gonna skip right to the, look at this, we can look at this guy. Well, maybe we won't mess with the toy.
Couldn't get that teaching toy to work either.
Which one?
Power quality teaching toy under.
Okay, let's look at, this.
Download.
Okay, I'll take a look at that. So I go through the power factor here. That's your resistance, there's your current side. Adding up current is your I-94 going through your resistor in the pipe, in your system. Inductive loads, and again, the inductive loads are those power factor losses. It hasn't happened in this country, power factor, to kind of know. This is probably the best screen for it right here. So there are three separate ways. This is me talking in real time, explaining last year's explanation for power factor. But there are 3 separate ways to measure power. This one, called real power, is if all of the loads on the circuit were just resistors. And this is really what you would like to pay for. The other 2, so if you look, this is kVA, so this is volts times amps. So you could have amps flowing through your system, but not being subjected to much resistance. And the classic example there is with a motor. So if the amps flow through your motor and then flow right back out through the meter, that's what's called apparent power. And so that's really the hypotenuse of the triangle. And then what's called the reactive power is just, it's the other side of that triangle. So real power is resistive, apparent power is capacitive and inductive. That's why I was going through all of this stuff right here. So in any circuit, you've got resistors. So that's resistance times current plus inductance times the time derivative of current times the integral of current over the capacitor. So these last two, inductance and capacitance, don't, they just store power. The resistor dissipates it. And so this is really what you would like to only be paying for, not the stuff that you're sort of storing, but the stuff that you're cooking off as heat, more or less. So getting back to where we were, there's that little triangle here. Oh, there it is right there. I think I've got some good notes on it too. Let's pull that up. Yeah, okay. So the power factor itself is the well, it's the kilowatt hours, and this is the resistive power. This guy is that hypotenuse of the triangle. So I don't know if this is the way you've seen it in. I don't know if this is the way you've seen it in the other class or not. But this is the apparent power. This is again the real. And what I'm showing here in this little bit of algebra is that if you have the power factor, you can then get the apparent power algebraically. So what I'm showing with this little bit of math is if I multiply both sides of the equation by this denominator, I basically get the power factor times that square root equals the real power. From there, I just square both sides. So I've got the power factor squared. Everything under the square root is now just its normal self. The real power gets squared, and then it's just a matter of solving for kV. So I divide both sides. My little notes are off to the side. So first of all, you multiply by the denominator, you square both sides, you divide by power factor squared, so it comes over to the right-hand side, and then you subtract kilowatt hours from both sides, and then you're left with apparent power. And then just simplify. So again, if you know the power factor, you know the real power, you can then solve for the apparent power. That's just the algebra on that guy. I know that comes up in week 5. So taking this, initially kind of nasty equation and simplifying it out to the point where apparent power equals real power times the square root of 1 over power factor squared minus 1. And I know that comes up here in week 5. Okay. So it looks like last semester's YouTubes are working just fine. Definitely suggest hitting those. I do know that the iTunes U videos are no longer accessible, so I'm just going to go ahead and delete them. Get rid of those guys right now. then let's just take a look at this other little spreadsheeting deal I did.
One moment while I search roofer.
Unfortunately, Tom Javins retired. He was one of our big
Is
this one that wasn't downloading?
Yeah, I could,
On the
I could
Cross
do
Committee.
the setup thing, and then I wouldn't do anything from there.
Powerstandards.com. We'll take a look at it here in a second.
So what code do they want to put the new PD on?
Excel if statement for this calculation. Oh, and I do want to go over the if statement. Comma, one. I did that. Okay. I did that. Did you, are you okay with the if statement? Okay, so if I put in, work out for you, I'll go through it here.
Yeah, that'd be good.
I'll go through it too. Pressure average below 9.7 shall be as follows. So the number is 0.97, and the rate is 15 cents, 0.15, right? So this is, I'm just going to watch this for a second. Power factor, and this is rate, and this is in dollars per kilovolts. Yeah, the reason I'm confused on that is it's kilovolt amp hours.
Right.
The R just means it's reactive. It's
Ah, yeah,
the third leg of the
yeah.
term. Like, what the heck is the R? But the R just means reactive. That's all it means. What's the R? Well, it's the reactive. Zeros.
So it'd be 0.0015.
Unless specifically otherwise agreed, the
Here's the equation I just solved.
So if you go below 85, they're going to shut you down. Average. So we already have the average power factors calculated. Equation, kilowatt. Okay, that's where I solved that. So what I just did, and I had to put, here's where you can do some simplification.
There's the fast version.
Kilowatt
It's just algebra. There's
divided
nothing.
by VARH equals kilowatt hours times SQRT, open paren, 1 divided by dink times dink. And, well, let's do it this way, just to be safe. This is where you can screw yourself up in Excel. Because you could either divide by the square or divide by the same thing twice. And again, if you're ever confused, go back to some simple little algebra arithmetic that you already know. So I'm gonna divide
That's
by
always confusing.
that
You've got a multiplication in the
times
denominator.
that. I think my dear Aunt Sally gets a little
But that's one way to
confused
do it,
with
is just
sometimes.
put in parentheses and multiply it.
Minus 1 close parentheses. So we got my kilowatt hours out front. That's my I5. Got my square root. I've got the inverse of power factor squared minus 1. And I'll just do a 0, 1 on my if. So equals if that is less than that, then I get charged. If not, I don't get charged.
I just made it really simple for us. It's just going to be a 1 or a 0.
Okay.
Got to put a reference on it. It's going to be $4. There's only 1 month where I don't get charged because I've actually had a high power
See
factor.
how that little if statement worked there?
Yeah, it's a little hard to,
I know the screen size isn't that great, isn't it? I should have made it bigger.
Charge is going to be the KVAR times whatever the cost is. I got to put an absolute reference on that. Control 1, currency,
let's go back to
I
the
think, save.
I'll go over it again here.
Okay, so just to review, we downloaded the data, we knew the kilowatt hours per month, we knew the power factors per month, and I think we have a pretty good idea of what power factor based on the horse drawing, my cars on the highway analogy, and et cetera. We were able, I hope, to calculate the KVARH. What's that R doing in there? I mean, I can see kilovolt
It's the reactive.
hour.
I've actually done a little bit
What's
of
the R?
engineering on that recently.
Right? Kilovolt amp hours.
It's the reactive part. The Google should,
Brad Layton. Oh, hey, Scott. Hey, I'm still in lecture. Are you on main campus? Okay. Are you going to be sitting tight there for a little bit, or do you want me to come find you? Call me in call me at like 3 minutes, or 10 minutes to 3, and I'll find you. All right, bye.
okay, I'm gonna stop that. Okay, so let's actually go in and, this is a week 5. I'm gonna go back through that same, there it is. Okay, make this a little bit bigger. And I also wanted to double check this. So here's each month. It's just January, February, March, April, May. Also, another kind of cool feature in Excel. So if I type in January and type in February, and then it actually just filled it in for me automatically. So that will happen either that way or by dragging it. That's kind of a built-in feature. Each one of these things is the kilowatt hours, so that's how much real power flowed through the system, so 201,000 kilowatt hours, 198, et cetera. These are the reported power factors. And then let's just see how my calculation did. So the calculation just equals the power, which is in I5, and I'm going to multiply that by the square root of 1 over J5 squared, or the power factor squared, minus 1. And that is identical to this formula. So all I'm doing right there is just putting this, this formula for and I should go back here and actually state that this is KV. This thing actually is KV, let me write it out. KVARH. So this is the reactive power. Throughout the problem, I just wrote it in there as KV, but this is in fact what they're charging for. Okay, so it's KVARH. There's the formula. Now I put in just an intermediate if statement. So this says if J5, which is the power factor, if it's less than $4, so in words, the power company would like you to have a power factor of 97 or better. If you don't, you're going to get charged for it. So in every single case but one, this one single month, they had a power factor worse than 0.97. So the if statement holds here and returns a 0. Now the charge is going to equal the kVAR times the charge. Here's where I left out. I'm looking at that thing like, wait a second. It equals that. It actually equals the if statement times that. So if it's a 1, it returns the same amount. If it's not, there's a 0. That's kind of the power of the if statement. It just gets rid of the whole thing.
Where did the question says use the Seattle City Light power factor? Where do we find that?
Oh, let's take a look. Where were you reading that?
That's in the instructions for
Week 5? Week 4?
Week 5 question or problem 1.
So it's going to be right in here?
Yeah. Seattle City Light. This afternoon meeting.
You said this guy wasn't working either?
Yeah, I couldn't get it to work for me.
Were you doing this guy? Going
Well, I
through all
tried
this?
both. I didn't get anything on a PDF, and then I got the zip file, but all it is an install. And then you're like, okay, install it and run it. Nothing happens.
Let's take a look. What am I doing wrong here?
It says click that.
Oh, there we go,
And then
okay.
you,
That's fine, doesn't matter.
well, maybe put it somewhere in my computer, I just can't find it.
Oh, it's back here, yeah. Alex, okay, cool.
Oh, okay, so I probably do have it. Is it Alex?
Alex McEachran.
Oh, there it is. Okay. There it is.
This is kind of fun. Yeah, so what we're looking at here is
Yeah, that's cool.
this is a perfect power factor where volts and amps are exactly in phase. See the two top white lines, and well, when you multiply 0 by 0, you get 0. That's what those are. When you multiply this peak by that peak, you get that peak. Here's your zero crossing, etc. Watts can't be negative, so you're going to multiply, positive amps times positive volts to get positive watts. Negative volts times negative amps is going to give you positive watts. So there's your AC power in action, and still positive power. If we go over here and reduce the power factor, let's just take it down to like 80. You can see that the volts lead and the amps lag. Come down over here. You can see that the amps are leading and the volts are lagging. You can still have the same power factor because you're just dealing with the triangle, but that's the difference. Oh, yeah. I see now. This is pretty good. So there's actually a time where you're making negative watts. You're actually instead of consuming watts, you're actually pushing them back out onto the grid. I see this now. This is actually kind of cool. Okay, interesting. And then by dragging this guy up here, let's see. I mean, we can keep the same. Let's just show that we could have 90 power factor 90 here. Here, really all I'm doing is keeping the angle the same, just increasing the amount of power.
Huh. That's pretty cool.
That's pretty cool. Cool. All right. So there's a neat little power factor teaching tool. So that works. Then you said you were looking for the Oregon standards?
The Seattle City Light.
Seattle City Lights,
It says
okay.
use the power factor schedule for Seattle City Light, and then you kind of do all these calculations for problem one.
Okay.
Add it there.
there's this link right here. Is this it?
I didn't see,
Okay, all right. Use the power factor schedule for Seattle City Light. Calculate power factor changes for each month. Use the if statement. I think that's the data we just did. Yeah. Yeah. Yeah, there it is.
it's below 97.
Yeah.
Okay.
Yeah, yeah, yeah.
If it's less than that, then.
Yeah, so we just went over that. Cool. Cool, nice. All right, so I think we got a few of those things cleared up. I'm going to take a quick break.